Now I will explain here how to start a laptop motherboard. First you should know laptop power sequence. That means how to start step by step. See here, this is power sequence of laptop motherboard. First, number 1, this is RTC battery. From this voltage goes to ICH supply. This voltage goes to ICH and reset, RTC reset voltage also goes to ICH. This is ICH. Battery voltage and ICH, RTC reset voltage goes to this ICH. First, this voltage goes to. If it is short, set dead. First, you should remove CMOS battery. First, you should remove CMOS battery. 2. VDC voltage DC. This is 18 volts or 12 volts DC. This voltage comes from adapter, DC adapter connector or battery connector. Always power. This regulated voltage goes to 5 volts and 3.3 volts. 5 volts and 3. This voltage goes to 5 volts and 3.3 volts regulator IC. This is DC adapter connector. This voltage 18 volts goes to this voltage 5 volts and 3.3 volts IC. This is battery connector. From this connector 12 volts DC comes to this IC. This is 5 volts and 3.3 volts regulator IC. This voltage release 5 volts and 3.3 volts. This 3.3 volts goes to ICH IO controller IC. This voltage goes to IO controller and reset circuit and bias chip. This is 3. So this regulator IC 5 volts and 3.3 volts. That 3.3 volts goes to this IO controller IC and bias chip. This is bias chip. This 3.3 volts goes to this IC and this IC. From this regulator to 3.3 volts through RST reset circuit. Reset voltage goes to IO controller IC. So from this IC 3.3 volts IC goes to this IC supply pin and reset pin also. When you press power button, this pin, that means microcontroller IC, that means SIO controller chip pin ground from through power switch. This voltage, this pin have 3.3 volts supply. When you press power button, this voltage goes to 0 and this function will start. This KBC suspend power voltage comes to the max IC, that means 3.3 volts and 3.3 volts regulator and 5 volts regulator IC, and release 3.3 volts and 5.5 volts voltage. See here, when you press power button, this voltage comes to this IC. This voltage comes to this IC. This is IO controller. This voltage, power button connected with this SIO chip. When you press power button, this power pin goes to 0 volts. 3.3 volts to 0 goes to 0 volts DC. It will start this function and this suspend voltage goes to this IC. This is 5 volts and 3.3 volts. That regulator voltage releases this IC. This voltages come out from this ICs. 3.3 volts and 5 volts release from this ICs. See here, 3.3 volts and auxiliary supply. 3.3 volts and 5 volts voltage comes out from these coils. Suspend power on 3.3 volts goes to the 5 volts and 3.3 volts regulator IC and memory supply regulator also. This voltage DDR2 1.8 volts supply auxiliary. When this 3.3 volts comes to this IC and this IC, this voltage release, this regulators release these supplies 3.3 volts, 5 volts and 1.8 volts. This voltage comes to this 5 volts and 3.3 volts. This coils output will come out from these coils, 3.3 volts and 5 volts. This is memory regulator IC, memory regulator. This is that command also comes to the memory regulator. This is memory oscillator IC. This voltage comes to this 3.3 volts comes to this IC. This voltage goes to this outputs. This 1.8 volts come out from this coil. When the 3 voltages auxiliary supplies is okay, this voltage comes to SIO chip. Suspend power good voltage is okay. When this voltage is okay, this suspend power okay voltage goes to SIO IC, SIO controller. When the suspend power good voltage comes to this SIO chip, this KBC, that means RSM reset 3.3 volts goes to ICH supply, ICH chip. 3.3 RSM reset 3.3 volts goes to ICH. RSM reset 3.3 volts goes to this ICH IC. When RSM reset 3.3 volts and power button voltage 3 volts goes to 0 volts. When this 2 voltage receives ICH, this immediately this chip release SLP S4 3.3 volts, release SLP S4 and S5 to SIO chip. When SLP S4 voltage, when RSM reset voltage comes to this IC release SLP S4 and S5 3 volts to this IC. SLP S3 voltage 3.3 volts also goes to this IC, microcontroller IC. SLP S3 3.3 volts goes to microcontroller IC. Run power or power on voltage 3.3 volts from microprocessor IC, microcontroller IC, that means IO controller IC to 3.3 volts goes to different regulator ICs, that means 0.09. This voltage goes to memory termination. This voltage 1.25 and 1.05 volts. This voltage goes to north bridge and CPU. GFX core voltage, this voltage goes to graphic controller, that means this chip. This voltage 1.5 volts and power 5 volts, 3.3 volts and 2.5 volts, 1.2 volts. All these regulators, this is all regulators. This run power command comes to this IC, 3.3 volts comes to this IC. This voltage will release from these regulators. See here, all these regulators and these regulators and these regulators and these regulators, this all voltages comes out from these regulators. This will release output voltages. These regulators voltage release, this one of the regulator and this regulators IC also release output voltages. When this voltage is okay, this from this regulators to voltage goes to IO controller. When this power supply is okay, this power good voltage goes to, see here, this is incoming 3.3 volt, 3 volts comes to the switching regulators. When this supply is okay, this power good voltage goes to VCC, power good voltage goes to SIO chip. That means this SIO chip. These all regulators release power good voltage to this SIO chip. This voltage goes to SIO chip. This power good 13. After this voltages release 1.8 volts and 1.2 volts, 14 and 15. See here. When all these voltage regulators is okay, in this SIO controller release VR on voltage to CPU regulator IC. CPU regulator IC, VR on voltage to CPU regulator IC. This voltage, when this power supply voltages is okay, power good voltage goes to this IC. This IC release VR on voltage to CPU regulator IC. This is CPU regulator IC. This voltage goes to, this is CPU outputs, this is CPU output, regulator outputs, this is coil, output coils. From 1.2 volts from release voltage release from this coils, this voltage goes to CPU. This is power regulator, CPU power regulator. This voltage, all power supply is okay. When all power supply is okay, this voltage goes to IO controller. That voltage, that is released VR on voltage to CPU regulator. This is CPU power regulator. When this VR on voltage comes to this IC, this regulator release VCC core voltage, that means CPU power supply. When this supply is okay, the power good voltage goes to ICH and IO controller. This IC, this is 16, this is 17. This voltage goes to VRM power good. See here, VRM power good. This is ICH. VRM power good. This voltage goes to this IC, ICH. When this regulator is okay, this regulator IC release VRM power good voltage to this ICH and IO controller. When CPU power is okay, this ICH release clock power good voltage to clock generator IC. When this voltage power CPU power regulator is okay, this IC release, this is clock generator. This is clock generator IC. This is in this bottom side, clock generator IC is there. This VR clock power good, clock power on voltage goes to this regulator IC. This clock generator starts clock signal, and this clock signal goes to all chips, CPU and GMCH and IO controller and ICH, and this is graphic controller. All clock signal goes to all these ICs. This clock running signal goes to all ICs, all chips. This is 19. After clock signal, see here, power good GMCH voltage. When this clock signal goes to microcontroller, this release power good voltage. That voltage goes to ICH and GMCH. See here, power good MCH or GMCH, graphic memory controller hub. Power voltage will release here. When this voltage release and 20, when this voltage release, CPU power good, when this voltage release, when this voltage received ICH, this ICH release 3 volts power good voltage to CPU. ICH release CPU power good voltage to CPU. Next, the ICH, when this ICH is okay, this PLT reset and PCI reset voltage release from this IC 3.3 volts. You should check here, 3.3 volts is present, ICH is okay, all this 22 connections, that means 21 connections is okay. This voltage goes to GMCH and graphic controller chip. When this voltage will release RSM reset, this power good voltage goes to CPU. CPU starts this function. When ICH received power good voltage, this is release PLT reset and PCI reset voltage 3.3 volts. That voltage goes to GMCH. The GSM when this IC is okay, when this PCI reset or PLT reset 3.3 volts received this IC, this starts this function. Then when this IC is good, this is release H power good, that means host power good voltage 3.3 volts released to CPU. CPU will start that function. This voltage goes to LCD connector and graphic control connector. This voltage goes to VGA connector and S video connector. Then display will come. When this signal goes to LCD panel and VGA connector and S video, display will come.